Good morning, students. Today we are going to discuss few more topic from chapter 10, Mechanical Properties of Fluids. Now, the first topic which you are going to define is your hydraulic machine. Basically, hydro means water. So here, liquid basically used to operate this machine. Now, this machine works on the principle of Pascal's law. Now, let me explain. You see. Here you do have a almost alphabetical U-shaped container, one with area of cross section A1 and another with area of cross section A2. Now these areas are enclosed by the movable piston. Okay, you see over there is an handle, so you can block the opening by using this piston, and this one is movable piston, it's not fixed, just you have to block the area. Now area of cross section of A1 is less than that of area of cross section of A2, then less than the area of cross section A2. So here the container is closed by two piston with different area of cross section, one with A1, another one with A2. Now what we will do here, the liquid is there. Now as per the Pascal's theorem, it says that pressure transmits through the liquid with undiminished magnitude. So that principle we are going to use it here. So what we will do, we will apply force on the piston whose area of cross section is less, that is here A1. Now when we apply force F1 on the piston with area of cross section A1, so definitely a pressure generates by using the definition of pressure equal to force by area, and that pressure gets exerts on the liquid. Now that pressure transmits through the liquid with undiminished magnitude, and it gives a upward thrust or upward pressure or upward force on the piston with area of cross section A2. So as a result, what will happen? The piston with area of cross section A1 gets down, and piston with area of cross section A2 moves up. Now as per the Pascal's theorem, as the pressure transmits with undiminished magnitude, so you can write F1 by A1 equal to F2 by A2. Now you see, if you simplify, F2 equal to A2 by A1 into F1. Now you see, F1 is your applied force and F2 is the generated force. Now in machine basically we need output high compared to the input. So here output is your generated force F2. So let me see this equation, F2 equal to A2 by A1 into F1. So you see in the figure, A2 area of cross section is of the piston with area A2 is of higher value compared to area of cross section of the piston with area A1. So as A2 is higher than A1, so definitely you can say F2 is greater than F1. So you see the magnitude determining factor for the generated force is nothing but the ratio A2 by A1. If you consider A2 very high value and A1 very less value, then F2 will be very high. So you see, by applying a smaller magnitude of force, we are generated a higher magnitude of force. So it means the input is low but output is high. That's why this is a machine. Machines basically have output high and input low. So here we are going to use the strange property of the liquid as put forward by Pascal, and that one is pressure transmits through the liquid with undiminished magnitude. So what we have written, thus with the application of a small amount of force, large force can be generated. Now let me define some more fact of the liquid, and that fact is your streamline flow. So what we have written, let me read out. When the flow of liquid or when the flow of fluid is such that the velocity of every particle of the fluid at any point is constant, then the flow is said to be steady or streamline. Let me repeat, then we are going to explain. When the flow of fluid is such that the velocity of every particle of the fluid at any point is constant, then the flow is said to be steady or streamline. Now how can we explain this one? You see, this is your pipe, you can say, through which the liquid is flowing. So we have given a dotted sign at the center of the pi. Now we have specified 2 points A and B, and A and B is characterized a specific point inside the liquid, and the velocity at A is v1 and velocity at B is v2. So as the liquid is flowing, so any particle of the liquid, when it reaches at A, its velocity comes out automatically to be v1, and when it reaches at B, its velocity automatically comes out to be v2 under the condition that the flow is streamline. So in streamline flow, there is a defined velocity at a specific point. So when the particle reaches at that specific point, it acquires that velocity as it is specified at that point. So here specific point is your A and B, and the specified velocity is your v1, v2. So whatever particle comes behind A, but when it reaches at A, its velocity automatically comes out to be your v1, and when it reaches at B, its velocity automatically comes out to be v2. So if this happens, then that flow is said to be streamline flow. And the derivation which we are going to define now onwards, we will consider the flow is your streamline. So one statement I have written here: the path followed by the particles of a fluid in a streamline flow is called streamline. Okay, it's a line, no, streaming. So in streamline flow, the velocity is already defined at that specific point. So whenever liquid particles comes at that specific point, it acquires that velocity. Now the next topic, that's a very important one, equation of continuity. Now you see, you do have a different area of cross section tube through which the liquid is flowing. Now here we have considered two specific points, A and B. So at A, the area of cross section is your A1, at B, the area of cross section is your A2. So as the liquid is flowing, so the liquid which is available at a specific time at A moves to A dash within the certain specific time interval. And similarly, the liquid which is available at B reaches at B dash at the same interval of time as we have specified. The liquid moves from A to A dash. So at two different points, it has two different velocity v1 and v2, and the movement is also different because the area of cross section is different. One is your delta x1 and another one is your delta x2. Now you see, equation of continuity expresses the law of conservation of mass. So it says that if the time interval considered constant, then the amount of liquid moves from A to A dash is same as the amount of liquid moves from B to B dash, though it has different velocity, different area of cross section. This is your conservation of mass. So if we consider if rho be the density of the liquid, then amount of liquid moves from A to A dash is your rho A1 delta x1. So that is your volume. Volume into density gives you the mass. And here volume into density, that is your volume is your A2 delta x2. So rho goes off. So if we consider fixed time interval, then let me consider that interval is a delta t. So numerically or mathematically you can divide both sides with delta t. So when you define delta x1 by delta t, it gives you the velocity v1, and delta x2 by delta t gives you the velocity v2. So you see a1 v1 equal to a2 v2, v1 equal to delta x1 by delta t, and v2 equal to delta x2 by delta t. So whenever a1 v1 equal to a2 v2 occurs, then you can say ab equal to constant. So area of cross section and velocity is constant. It means if area of cross section is less, then the velocity is high, and vice versa. Now next topic which we are going to define, that is your Bernoulli's theorem. Now equation of continuity define the conservation of mass, and Bernoulli's theorem specifies the conservation of energy. So here again the same diagram almost, only the specific level is given, and the height comes out to be your, at A is your h1 and at B is your h2, and the velocity v1, area of cross section a1, pressure is p1, and here is also pressure is p2, velocity v2, and the movement is your delta x1, and another one is delta x2. So let me read out what we have written. It states that the sum of pressure energy, kinetic energy, and potential energy per unit mass is always constant. So till now we know kinetic energy and potential energy, but here we are going to consider one more energy, that is your pressure energy. So kinetic energy, if we consider, the formula is your half mv square. So if we consider the mass, then it comes out to be delta x1 a1 rho, that is your mass, and velocity is your v1, so v1 square. So kinetic energy per unit mass is your half v1 square. Similarly, potential energy, comes out here. Mass is your again delta x1 a1 rho and gh1, so mgh1, so potential energy per unit mass comes out to be your gh1. See the diagram and try to find out the expression. This expression is very simple. And the pressure energy per unit mass, pressure, if we consider this part, pressure is your P1. So pressure energy, so work done by the pressure, that is your P1 A1, that is your force, and delta x1 is the distance. So that is your work done by the pressure energy. And mass is your rho A1 delta x1. So if you simplify, it comes out to be your P1 by rho. So similarly, you can get at B with the specific parameter. So your kinetic energy per unit mass half m v2 square, because v2 is here, and potential energy per unit mass is here again gh2, because h2 is the height, and pressure energy per unit mass comes out to be your p2 by rho. So from the theorem it says that sum of the pressure energy, kinetic energy and potential energy per unit mass is always constant. So if we sum it up, it comes out to be your v1 square by 2 plus gh1 plus p1 by rho, v2 square by 2 plus gh2 plus p2 by rho. So in general, if you say v square by 2 plus gh plus p by rho equal to constant. So v square by 2 is your kinetic energy per unit mass, gh is your potential energy per unit mass, and p by rho is your pressure energy per unit mass. So this is your Bernoulli's theorem, and Bernoulli's theorem defines the conservation of energy, and equation of continuity defines the conservation of mass. So this is all about. Please go through and compare these all with the standard reference book and try to clear your queries. Thank you.